Hey guys, just want to do a quick recap of what we've covered so far. Okay, so here we got our good old brother Coulomb. Okay, Coulomb's moving on, and how fast it's going is called. You are right. It's called the current. Okay, so if it's moving fast, what we'll say is that he's got a high current. If it's moving slowly, he will have a low current. Okay, and you can see how much energy does he give up before he has 5 joules, after he has about 2 joules. So 5 minus 2 equals 3 joules of energy. It's also known as, you are right, potential difference. Okay, so potential difference is basically just the amount of energy that Coulomb actually needs to go through a component or a resistor here. Okay, oh, what's a resistor? Okay, so resistor, you're right, it basically just resists brother Coulomb. And what other character can resist our brother Coulomb, who is a commando? Okay, the only one is he's got to be superhuman, and that's Incredible Hulk. Okay, so Incredible Hulk, you can take him as a resistance to Coulomb. Okay, so let me just ask you a quick question. Okay, let me just to introduce you to the concept of resistance. If I were to increase the resistance, how will the resistor actually look like? Okay, instead of one Incredible Hulk, we've got, oh yeah, you said it. Okay, we've got 5 Hulks here. Okay, so with 5 Hulks, what do you notice about Brother Coulomb right now? Okay, so Brother Coulomb, first thing you notice is goes slower, right? He actually moves slower, and at the same time, he needs more energy. He previously with 1 Hulk, he needs only 3 bars, and right now he needs 5 bars of energy, right? So it makes a little bit of sense with by increasing the resistance. Okay, so in other words, the current decreases and potential difference increase. Okay, with an increase in resistance. Okay, with that, just go into a little bit on relationships. Okay, so resistance you can see is proportional to potential difference, and at the same time is inversely proportional to our current. Okay, so with that, 3, 2, 1, boom, the relationship you see. Okay, our resistance equals V over I. This will be our new formula to calculate resistance. So basically, what is resistance? It's just the ratio of potential difference to current. That's it. Where R is resistance of a component, V is potential difference across the component, and I is the current flowing through that component. Okay, and SI unit, we know for potential difference volts, current is amperes, but resistance, is it volts per ampere? Nope, we've got a shortcut for that too, and the shortcut is the ohm, okay? Just the ohm. So how do we measure potential difference? Let's say if I got a lamp here, okay, to measure how to measure the resistance, okay, to measure the resistance, okay, first we will swap that light lamp with the symbol for a light. Okay, and like what I mentioned just now, we need to measure 2 things, right? The current and the potential difference. So first, connect an ammeter in series and boom. Okay, so with this ammeter in series, you will measure the current, right? You've got the value for I, and after that, connect a voltmeter in parallel and boom, okay? And this, you will measure the potential difference V. Okay, so you got the potential difference V, you got the current I, and that's it. Check out this space here. In 3, 2, 1, boom. Okay, basically you will be able to measure the resistance. That's it. Okay, so what are resistors? Resistors, there are 2 types of resistors. You got fixed resistors and a variable resistor, also known as a rheostat. Okay, so this one you can vary the resistance. That means this slider here can move left or right. Okay. Um. Okay. So with that, let me just introduce you another way of looking at resistance besides temperature. Okay, you know that the resistance will also depend on first its length as well as the cross section area, and finally also the material, right? So in other words, the longer the length, you will see, of course, the resistance will be higher. Because why? Because it'll take Coulomb more, it'll need more energy for Coulomb to travel a longer distance than a short distance. Okay, what about cross-section area? The bigger the cross-section area, the more space Coulomb has, the easier it is. So that's why it is inversely proportional. Okay, with that, I give you the second formula for resistance. You ready for this? And boom! Okay, so resistance, you can see this is rho. Rho is basically just a constant for the material. For example, the material is made up of a certain particular material. They have a value for that specific material. Okay, but the main thing is that you know that it is proportional to length and inversely proportional to area. That means the longer length will result in in the higher resistance, and a larger cross-section area will result in lower resistance. Okay, so just a couple of a table of resistivity, the rho value. You can see different materials have got different resistivities here. Um, it's basically just a property of material. So the higher the resistivity, higher the resistance. So of course, for a wire, we need something with very low resistance, right? Okay, but why are most of our wires not made of silver, but they're made of copper? You in the corner? That's right, because silver is very expensive. Okay, anyway, copper is not far behind, so you'll choose copper mostly, usually for making of low resistance wires. Okay, all right. So just a quick recap. So far, we have done all this. If you haven't watched my video previously on current, EMF, and potential difference, do check it out. Okay, what we've covered today is the concept of resistance. Okay, so we've got resistance, R equals V over I, first formula, and second formula, R, resistance can also be measured with this new formula, rho L over A, cross-section area. Okay, so this is a quick recap of what all the entire um, uh, chapter on current of electricity. Okay, we've touched on the first four: charge, current, EMF, potential difference. You can see here, uh, current is always measured in series, EMF, potential difference, is always measured in parallel. Okay, today we touched on resistance. The formula symbol for resistance is R, and the unit is actually the ohm. Okay, and two formulas here: R equals V over I compared to R equals rho L over A. Okay, what's the difference between the first and the second formula here? Okay, you can see first formula here, actually in short, these values here, potential difference, current, you can't see. You basically don't see any of them, okay? All right, doesn't mean you cut a wire, you can see, oh, brother Coulomb's inside. No, you don't see any of them. You need an ammeter and a voltmeter to measure it. Okay, for the second formula, rho L over A, yes, all these you can see and observe and measure them. They are basically physical quantities. Okay, like the length, the cross-section area, all these you can see. Okay, so with that, I hope you enjoyed this video. All right, I'll see you guys in the next.